All right, welcome back to our asynchronous series. We're going to call this asynchronous 2.1 because we're in the second term. I don't know. Today is the day we're going to put it all together. So the first thing to note is that we are building a unit circle. A unit circle is defined as a circle with a radius of 1 centered at the origin. Ta-da, this is what it would be, right? So we have a circle and you can see the radius. The center is at 0, 0, and the radius of 1 we can see all around. What I want to do today is finally put together really the 3 basic triangles we've been talking about. So we've got 3 situations that we've been building on the unit circle. The first is when I have a 30-degree angle or pi over 6 radians. Right, the 30-degree angle or pi over 6 radians will look like this, where again, that angle right here is 30 degrees, pi over 6 radians. And essentially the thing to think about is we know that the radius is 1, and so what about the other measurements? And what I want you to draw back on is that 30, 60, 90 right triangle, where the 30, 60, 90, as a reminder, was half of an equilateral triangle. So that if originally each side here was 1 and I cut it in half, we know right off the bat that this side is a half. And then we saw a video talking about some special right triangles, some ways that we found this, or you could use trig. It might look a little different with your denominator. Whether you use Pythagorean theorem, you use what we learned about special right triangles and the relationships here of the short leg being double to the hypotenuse and then being times the square root of 3 to the third side. You can go back and review those videos if you like, or you can take it at face value. Either way, convincing yourself if the hypotenuse is 1, the short leg is a half, and then the other leg is square root of 3 over 2, which lead us to the coordinates of this point. The coordinates of this point, the x and the y on the unit circle for 30 degrees or pi over 6 radians is, of course, root 3 over 2 and a half. The other triangle that we have seen was the 45-degree angle, or again, pi over 4 radians. Here. Same thing, we know this is a 45-degree angle as measured in degrees, or pi over 4 as measured in radians. Either way, because we are on the unit circle with a hypotenuse or radius of 1, we could find these other missing sides, like again you did in that special right triangle video a few weeks back, and we find that these sides are the square root of 2 over 2. You might have got 1 over the square root of 2, and these are in fact the same number. Really, we got the other one by rationalizing the denominator. Maybe you've heard of it. That would be a good extension if you wanted to follow up. But to rationalize the denominator, we don't like square roots in the denominator. Multiply both numerator and denominator by the square root of 2. And that was what gives us this. That's just a little bonus. Either way, though, we see that the side lengths of this 45, 45, 90 right triangle are both root 2 over 2, which also give us the x and the y coordinates for this point here. And as a little preview for your asynchronous assignment, it follows then, of course, that if I took this triangle and I flipped it over here, the side lengths don't change. And when in terms of coordinates though, this is no longer the same coordinate because now we are in quadrant 2, quadrant 1, 2, 3, and 4, moving around the grid. And in quadrant 2, we know now our x values are negative, right? So this would be something like negative root 2 over 2 for that point. That's our 45, 45, 90. The third triangle we of course saw, or the first one flipped, was the 30, 60, 90 again, but this time the angle here, that reference angle, is 60 degrees or pi over 3 radians. And the side lengths here should look familiar. That short side of the 30, 60, 90 right triangle is still a half. That longer side is root 3 over 2. And we can also check, because if this was a radius of a half, the x-coordinate right here should be about halfway, right? The x-coordinate here is half of my total radius of 1. And so it follows that the coordinates here are a half and root 3 over 2 for the x and the y coordinate of that point on the unit circle. Again, kind of another preview, because like we saw with the 45, 45, 90, I could also reflect this triangle down. And again, if I reflect it down and think about here, we would need a different degree measure. We'll talk about that in a moment. But the coordinates here are really similar, except now our y value is negative, and so this would still be positive half for the x, but negative root 3 over 2, because in quadrant 4, the y values are negative. Wow, so here it is. We are going to combine all of that together to make our complete unit circle. This is going to be a big culmination assignment, so if you have any questions, please don't hesitate to reach out. What I would like you to do, and you can see each of the triangles hopefully, right? This pink triangle just moved around the circle, so the coordinates should look pretty repetitive. I would also love you to recombine. You have already filled out these radian measures before, but I would like you to fill out the radian measures with the coordinates for each point along the unit circle. There are some filled in for you to keep you on track. I would love to see your work, answer your questions, help you in whatever way I can. Congratulations on making it through our first term, and good luck going into the second one.